Is the stream on? Yeah, it's like, no, it's like, all right. Well, hello. Testing. Hello guys. We're gonna start our event already. Welcome to this round's Ethereum Penang event. For our first speaker, we'll invite Julius, who's also one of our core Ethereum Penang members, and he's gonna speak about the intersection between crypto and blockchain. So let's welcome him with a round of applause. No, it's okay. Hey, hi. Oh, what happened? Hey, hi everyone. So I'm going to talk about the intersections of blockchain and AI today. So I believe a lot of you know about blockchain and AI separately. So who doesn't know either one of this? I think, yeah, everyone knows. Okay, as everyone know, and AI is the core technologies for the fourth generation industrial revolution. So by itself, it's a very distinctive technologies that everyone is very into it today. But on the very surface, a lot of people thought about these two technologies are opposing each other. For example, in AI world, there's a lot of tendencies for consolidations where the big tech companies trying to consolidate the compute and the data within their own organizations, um, as opposed to blockchain technologies where everybody is open, there's permissionless, and everyone can take part in it, right? So because of that, that relationship with these two, in the past, a lot of people doesn't think that these two technologies can work together. But today I'm gonna be here to tell you about it actually makes sense to actually have these two technology together to build a solution. Okay. I'm going to walk you through a series of use cases. Hopefully by the end of this presentation, you will get the idea of why it makes sense to have a blockchain together with AI. Okay. Because all these use cases are very different from each other. If you have questions, you can ask immediately. You can just stop me and ask me immediately. All right. Okay, the first one is decentralized data and AI marketplace. So in current world, right? So when we are doing AI inference and also training, right? So a lot of time these are done by the big company within their own data centers and using their own computing powers. And uh, these are something that they will, give me a second. They have there isn't any way for people to get into that because a lot of these resources needs financial support. And also, for example, if you look at the AI world today, you need the GPU to do the training and inference. And it's very hard for you to get a hand on those today, right? So it makes sense that we leverage blockchain technologies to democratize these things today. There are a lot of GPUs staying around, and there are data that is staying around that nobody knows, right? So for us, for AI models to excel in their area, you need data that is not in the public web today. And we can argue that today the models built by OpenAI or the XAI or Meta, those are the data from the public web. But there are a lot of valuable quality data that is locked behind the corporate firewall, and those are not accessible by those big corporate. So in order to incentivize people to sell their data, and in order for the AI companies to actually get quality data from sources that they have no access to previously, it makes sense that we can create a marketplace in blockchain to incentivize people to sell their data, right? There are, for example, you have, let's say, a very private data that belongs to you, for example, your MRI, let's say your MRI scans, right? Those are very valuable assets that a lot of companies wanted to grab hold of in order to train their AI models. There are AI models that was trained to predict certain disease, and they need a very quality data in order for them to train that. So this cannot be done today without a marketplace that span across different, I mean, not in the control of the big corporate, right? So so the blockchain gives you the tokenizations mechanism for you to tokenize your data and sell it on the marketplace. So you can wrap those assets as a token or ERC20 token and sell it on those marketplace and be paid in the token itself, right? And also the validator can actually ensure the data quality of those data being sold. So in today's world, the data are being validated by the company that purchased that data. But in the open, if we put it on the chain, and when somebody purchases the data, the validator itself on the chain can validate it and give scores about the quality of the data on chain, right? So, for example, if I hold a set of very valuable data that is not accessible by many people, I put it on chain to sell. There could be a scoring system that first been validated by a validator and give a score to it. And then people will look at that information and then decide whether they want to buy it or not, right? So that kind of mechanism is available if we merge it into with blockchain, right? Yeah. No, it's a whole marketplace itself. Who there will be different parties providing their service, right? So there are data providers who is selling their data. There are the model provider who is also giving their models, promoting their models, that letting people to use it. There are also people who can provide their service to validate data. So there could be different parties getting involved, depending on how we structure the whole marketplace. It's different players. So, but all these different players come together to form the whole marketplace as a closed loop. There's not a lot of technology today that can do that without a centralized party. So blockchain is here to help you to aggregate everybody together in a network, and each party is incentivized to provide their own service in their own expertise, right? Okay. This can be done in a very private way, right? So your data doesn't have to be out in the public. In the blockchain world, you can have a set of data, but it doesn't mean that you have to put your entire data on chain for people to see, because once you do that, there's no value to your data anymore. Everybody can copy, right? So blockchain allows you to do this without revealing your raw data. So there are certain technologies where you can still keep your data, but you can prove to the people who buy your data that you own this, and you are doing compute on your data and give the result of the compute to the party who to buy it without revealing your data. There are certain technologies today that we can do that, right? Okay, so there are some real-world examples at the bottom. So there are some interesting companies that's already doing this, selling data and selling their models, right? Okay, let me move on. This is quite similar to the previous one, but this is more on the lending of the compute, right? So if you look at AI, there's three different main components today: data, model, and compute. Compute is the GPU. In fact, today, we can argue that it's very hard for a startup to venture into the AI industry, which come up with a model, because first, the expertise is very scarce. If you look at the Metas, he's actively poaching people today. And if you look at the XAI, they have a whole data centers full of GPU. And it's pretty difficult for a startup to start with that kind of resources. One way to overcome it is to have a marketplace where people can actually sell their idle GPU resource. This opens up for the possibilities for new startups to come in who doesn't have enough resources, money to buy GPU, and even some startup has the money. There's no way they can get a GPU because NVIDIA has already sold out the next 2-3 years production to some companies, right? They have back orders. So with this platform that is built on blockchain, we can have the party who has the computing power come into the market, list down the GPU that can lend out, and allow scientists or users to actually purchase GPU time from them, and do their own inference or learning, right? So the training of the model. So, but it's easier than say to actually turn a centralized model training or inference from a centralized mode to a decentralized mode. There's quite a number of technology challenges there, right? So, for example, you have a piece of task that you want to train a model, right? but you outsource this to a party who listed their GPU on chain. And you say, okay, I give you this task, you must train this on this particular model and this piece of data, and you give me back the results, right? So, but how would you know the data that comes back from them is actually trained on that model and actually trained on that data? You are not there to see that. They only give you back the results. So this is one technology challenge that we have, and there are solutions to this today. ZKML is one of the solutions, zero knowledge machine learning. So there is a way for you to, for the people who do the compute, the person who actually lend out the GPU, to produce a proof using the GKML mechanism and give you back the proof, and you have a zero knowledge way to validate whether that person is using the right models and train on the right data, right? So it could be you're asking him to use this model and this precision, right? Maybe 16 FP precision is not the quantized one, but at the end of the day, the proof will actually prove it. So this is all using cryptography, and there are already companies doing that. So because of all these technologies, right, that makes this marketplace possible. So it opens up a lot of opportunities for new startups to leverage all this GPU power. Okay. I mentioned here also the model federated learning, right? So it's a piece of technology where you can break up a task, let's say a model training task, into small pieces and distribute out to different parties to do the training. And at the end of the day, you aggregate it back and you aggregate all together to form your final models. So that itself is a technical challenge, but there are already solutions that are proposed by different parties, including Google, to do that today, right? So that whole new advancement in technologies enable us to have this kind of marketplace today. Okay, right. Let's move on. AI enhanced smart contract and AI driven oracles. So today, we can say the smart contract is very smart, but actually smart contract is very dumb. It is just doing whatever that you coded it to do. So it doesn't have the capabilities to do something out of what you have already coded, right? So, but you can give the smart contract some intelligence by injecting the insights into it. So you can have certain AI insights that's generated outside of the chain, but you can inject it into your smart contract via an oracle, and then use that information to do certain things in your smart contract. So you're turning a very static, dumb smart contract into something that is powered by an AI insights to do a lot of things that you cannot be done earlier, right? Oracle is good at validating that the data is reliable, just like what Chainlink is providing. Chainlink is providing the price information from the off-chain world to the on-chain world, and Chainlink has a way to validate and aggregate the data from different parties and choose the right one to give it to you. So Oracle is very good at that. Same thing, we can apply this. There can be oracles to vet through all these AI insights and make sure that they are reliable enough to be consumed on chain. Okay. So this is another use case where the blockchain can actually help, the AI can actually help the blockchain. Yeah. Healthcare, this is quite similar to the previous, the data marketplace, but I specifically split it out to here because there are a lot of different companies doing this today. We have models today that is doing predictions and detections on different disease, and also they can just look at your CT scan or MRI, and then do some prediction whether how possible are you getting this sickness, right? So these are all being trained by the real data that is out there, but there are a lot of these data are being in silos where uh, like for example, they are within a single hospitals or organization. They are there. They are being locked down because of good reasons, because of security and privacy. But because of that, it is pretty difficult for someone to actually come up with a model, AI model that is performant enough to predict a lot of different diseases. The real problem is they cannot get hold of data to train a model, right? So this can be overcome by same technologies that I mentioned just now, where the patient or the people who provide those information or the medical information to train the model, they can retain the data without revealing them, and they can also take part in the model training without actually reviewing their data. So by enabling this, we can have models which was trained on a vast data that it can grab hold of from people without actually looking at the data itself, right? And as an end result, we can come up with a model that is very performant and it's also accurate on their prediction. Okay. Persistent data and context in AI interaction. So today, if a lot of us was introduced to AI by normally the chat interface, right? The chat GPT. So that most likely is the first interaction with AI for most people, right? So there's one problem with this is that every time we talk to the chat GPT, right? So it feels like a new sessions we are starting. So it doesn't know, so you're talking to the model today, then tomorrow you talk to him again, then it doesn't know what you have talked previously. It's just like you are starting a new page with them. It's like if whole new strangers that you're talking to. So this is so in a single AI application, like for example, ChatGPT. So you talk to him, to ChatGPT. The next moment, you have to reintroduce yourself and tell him your preference, tell him the output structure that you would like, and that kind of things. So even now, even more problematic when you move across AI application, like you move from ChatGPT to Gemini. That's even more problem because whatever you tell ChatGPT is not translated over to Gemini. Gemini doesn't even know what's your name, what's your preference, all these things. So to solve this problem, right? So we need a technology or mechanism that is not controlled by a centralized party, like for example, Google or OpenAI, because OpenAI would definitely not build some common infrastructures that will be used by another AI companies. So blockchain is one of the possible solutions to this. We can have all this user context information being written on chain and then shared across different AI application. So it's one of the possible scenarios. There are already companies trying to do this. Yeah, this is one use case where we can use blockchain and AI together. Okay. Universal identity for agent, right? So we are slowly moving from the normal chat based AI interaction to agentic AI, where the AI will perform certain actions on your behalf, right? So AI is the LLM or the AI is just the brain, right? The intelligence, but it cannot go out and do tasks for you, do stuff for you. But with this agentic AI, there are people coming up with technologies to enable that. Right? If you know about the MCP, those are the technologies that people put in place today to allow the LLM to come up with, make a decision and split the decision into tasks and allow the agents to go out to execute the tasks, right? But the agent today is very plain. It doesn't have its own identity because it has to represent you to perform certain tasks, right? Let's say, for example, you ask the ChatGPT to go and research a flight and purchase a ticket for you, right? LLM can do that. LLM can go out to the world looking at the website, trying to decide what flight is suitable for you and met your preference. And then it relies on the agent to go out and purchase for you. But agents today cannot purchase a flight ticket for you because it is not you. It doesn't have your credential, it doesn't have your bank account access, and it doesn't have an identity that the other parties or with the flight companies to validate that it is actually you, right? So it makes sense that we give an identity to this agent, and we can build this in a single AI application. Like for example, OpenAI can do this. In fact, now when you interact with ChatGPT, you are required to log in, and ChatGPT will retain your data, your preference, and if they want, they can actually have your identity data, your account data to go and purchase for you. But would you want to do that? Would you let go of your information to a centralized company like OpenAI, xAI, Google, to have your personal data to go out and make purchase for you? You wouldn't want that. So these are the problems today. It is arguably that blockchain is the only solution today in order to tackle this problem. Blockchain by nature is very open. It is composable, and you can program it to do whatever you want. And there's also kind of like a incentive mechanism built in place within blockchain, where you can make payment, where you can have identity that can port across different applications. So this is one of the examples where AI and blockchain can come together to solve this particular agentic problem. This is another examples of using blockchain as the registry of your intellectual property and also the provenance. So in AI world, right, today, Gen AI is very um, popular today. So everybody is using Gen AI to generate photos, videos, text, or whatever. Um, it's so proliferated, and a lot of people are not able to recognize whether this particular piece of photo or videos are generated by human or by AI, right? So there's a lot of problem out of that. You need to be able to tell a photo or the authenticity of a photo, whether this is a fake one or a correct one, because um, it can be used by certain malicious party to spread certain news that will affect maybe a market and affect people's life there. So blockchain can be one of the solutions to this problem, where you can timestamps your artwork, your data on chain. You can timestamp it. You can put your provenance data into the blockchain, and once you put that, it means that you own this piece of you generated this piece of content, and then you own it. You generate it at this date, this time, and because of the nature that the blockchain is tamper-proof, you cannot modify that data. And after the fact, you can actually prove that you generated this piece of data at which time. You are the owner of that. Okay. Okay. Another reasons why we want to do that is that a lot of content today are the lifeline of a lot of companies and people, right? An artist come up with a piece of work, it is their lifeline. They survive based on that. They are selling their things, their content or their artwork, and they survive on that. A lot of companies will survive on the content that they are generating. So there needs to be a way for us to attribute back the content actually belongs to these particular owners. For the sake of that, you need to allow the owner to claim what they're supposed to, or earn what they're supposed to earn, right? So with this blockchain records in place, it is possible, right? The only problem now left is whether whether your jurisdiction actually recognize what is in the blockchain or not. So that's a separate aspect to it. Okay. Micropayment that supports revenue sharing. So okay, okay, you can see today AI has been slowly taking over what people are doing in the past decades, right? Many years ago. So when people want to get certain information online, they go to Google, right? They search for the information they want in Google, right? But nowadays, I think most of the people don't do that anymore. So you just open up ChatGPT, you just ask a question, you immediately get the answer, right? So that's so convenient. And that also means the whole Google revenue model is gone, right? It's more than 100 billion revenue. Google's revenue is gone. So SEO is no longer a thing, right? So it's important that we have to think about how to redesign the whole revenue model around the AI technologies, right? So it's no longer depends on people clicking a link to monetize it, or It no longer depends on people to view certain contents. It's no longer like that. People just open up a chat interface, they ask a question, they get the answer. There's no link to click, there's nothing else to see, right? So for you to remodel or redesign the whole revenue model, you cannot run away from having a payment mechanism, right? So it's arguably that blockchain is the right platform to build that micro payment mechanism, because blockchain has tokens, has coins, which you can really do micro or even nano payment on content or whatever, because it's programmable, right? So you can't do this today in using current in the open world, I mean the off-chain world, because there's no without the centralization concern, right? So you wouldn't want the big tech company to own your payment and withhold your payment or whatever. Okay, so blockchain is of great help here. Okay. Okay, I've gone through all these use cases, right? So I hope you get the idea of these repeated themes. We keep on coming back to this decentralized AI. If you look at the advancement of AI today, you can more or less predict that eventually there will be an AI that being assigned, or not assigned, is tagged along with a baby when you're born, and the AI will learn through your childhood, learn about your preference, and help you do stuff in your life going forward, right? So that's the next step of this agentic AI. So in that kind of world, right? So you wouldn't really want a single company to own that AI, right? You wanted something that can be controlled by you and owned by you, right? So it makes sense that the foundation of that world is a blockchain. It's in blockchain, right? Because blockchain gives you the composability, gives you the openness, and you do not need anyone's permission to build something on blockchain. And you do not need permission for you to own something on the blockchain. And nobody can censor you away from the blockchain, right? So that's the repeated themes here. And I give some screenshots about what people has been doing. And Coinbase also dabble into these AI things. They came up with this agent kit for you to build agent on their chain. If you look at Bitwise articles, they predicted that 20 trillions will be there with this crypto and AI. And also World Economic Forum also talked about these technologies. So they are there. So I hope this presentation will give you an idea that this decentralized AI is a thing now, right? So when you're building solutions for AI, probably you can try to think about how would it look like in the future? Should blockchain be part of that solution? Okay, yeah, I think that's my presentation. Thank you, everybody. Is there any question? What are you most excited about? Me? I'm not sure. I'm still learning about AI, but I can see a lot of potentials in AI. But I definitely do not want it to be controlled by a company. My personal interest is to use it in education. I have a kid, a boy, which I find it I have really no time to really teach him on a lot of things. I was hoping that I can outsource that to AI and let AI go and scan his textbooks, picked up the knowledge point that he has to learn, and generate the content that is suitable for a 6 years old, and then go through a UI to talk to him and teach him that. I hope I can do that. Yeah. Yeah. Yeah, that's true. But if you think about that solution, right? So if the agent can help you to make a certain purchase, the purchase has to have your information, like for example, your credit card number, your login credential. That kind of information today, if you say that solution is possible, so that kind of solution today is being saved somewhere, right? It's being saved somewhere, and the question to ask is that somewhere being controlled by a company that you trust? Or are you comfortable to let the company own that piece of data on your behalf? Yeah, okay. If crypto, yes, that makes sense. That's one of the use cases. Any other questions? Okay, all right. Thank you very much. Okay, our next session is CK. He's going to talk about how to run a node, right? The animation. Oh, I'm not sure.
Hello. Yeah. Hello, everyone. Yeah. I'm CK from Lighthouse, Sigma Prime, and I'm going to give you an introduction about running an Ethereum node. Yeah, let's talk briefly about the general overview of the Ethereum blockchain. Blockchain is the database that is shared across all computers in the network. And in the case of Ethereum blockchain, we have more than 10,000 computers running the network globally, more or less about that figures. So blockchain is a network that's run by many computers together, and it contains data. And the database is updated to include new transactions from time to time. You can imagine blockchain. You can imagine a blockchain database as a book. When you want to include new transactions in a book, you can write them on a new page of the book. And in the case of blockchain, we include the new transactions in what we call a block. So the block will record the new transactions. And just like how pages in a book are tied together, forming a book, all blocks are chained together, forming blockchain. And one important property of blockchain is about decentralization, which means that no single entity controls the others. To understand decentralization quickly, let's talk about centralization, which actually Julius has mentioned it just now. For centralization system, think about, for example, our current banking system, where it usually has a centralized computer that's holding and controlling all the data. In this case, there's one single entity that controls all the data. If suddenly one day that the bank says that your account has only $100 left, and that's pretty much the truth, There are no check and balances. You can't really do anything about it. Not to say that the bank will do this, but you get the idea when one single entity controls all the data. Decentralization is the opposite of it. Just now we mentioned that there are 10,000 computers in the network. What is more important is that these 10,000 computers are run by different people, different entity, and therefore there's no one in charge. There's no single entity controls the other computers. And because of this, let's say there's one guy here running this computer trying to fake a transaction. For example, he wants to say he has the most money. And this transaction will be rejected by all the computers in the network. There are check and balances. Everyone has a say in a decentralized network. And this is why decentralization makes the Ethereum blockchain secure. And going back to one of the words in the title is, what is a node? The computer that just now we mentioned the previous slide that runs the network, they are the node. So you can think of a node is actually just a computer, and the computer will run certain softwares, where we call the software as clients. A similar experience you may have is, for example, if you have downloaded BitTorrent before, BT download, you download files or movies before, you will typically use a BitTorrent software, for example, BitTorrent, Transmission, or there are many other BitTorrent software, and they are actually known as BitTorrent client as well. So you will use the BitTorrent software or BitTorrent client, and your computer is actually a node in the BT network, downloading files or movies from the network. And applying the same idea to the Ethereum blockchain, if your computer is running Ethereum clients, then the computer is a node in the Ethereum network, and the node will also send and receive data from other nodes, or sometimes we call them peers in the network. Okay, so just now, yeah, I'm not sure why, yeah, anyway, why that? Yeah, just now we talked about the clients, so let's look at the two types of clients in the Ethereum node. We have the execution client and the consensus clients. These two types of clients form an Ethereum node, and the role of the execution client is to verify and execute transactions. For example, when you want to send a transaction using the blockchain, then there's a role of the Ethereum transactions to verify the validity of the transaction. So on the right of the table, we have 5 main execution clients in Ethereum: GETH, Nethermind, Besu, Aragon, RETH. You can think of them as the name of the software. Another type of client is a consensus client, also known as the beacon node. And the role for the consensus client is for all nodes to reach a consensus. What does that mean? So just now we say that there are 10,000 nodes in the network, and because they are distributed all globally, so you can expect some nodes to be far from each other. For example, there can be some nodes in Asia and then some in the US. And because of the distance between them, thousands of kilometers away, you can expect delays in sending and receiving the data. And therefore, at certain times, the nodes in Asia can see different blocks. Block A, which is different from the nodes in US, which is block B. So block A and block B will contain different transactions, right? So how do all these nodes come to an agreement on which one is the latest state of the network? That is the role for the consensus client. That is for all nodes to agree on the latest state of the network. That is to say, for all nodes to reach a consensus. We have 6 main consensus clients here. I'm sorry, this one is hidden a bit. We have Prism, Lighthouse, Teku, Nimbus, Lostar, and Grandin. And when you run Ethereum node, you need to run one consensus client and one execution client that goes in one pair, right? So any combinations will work. For example, you can run Lighthouse with RETH, or you can select to run Logstar with Besu, and you can run both of these clients in the same computer. Another third component, and that's optional one, is a validator client. That is when you want to become a validator in the Ethereum network, you need to send a certain amount of ETH to the Ethereum protocol, typically 32 ETH. This is also commonly known as staking. The ETH that you send to the protocol, you can think of it as a bond for you to become a validator in a network that allows you to participate in the voting process. Okay, that is gone now. Yeah, good. Now, just look at the simplified diagram of what we talked about the client just now. So when you run a node, you need an execution client and a consensus client. And these two things forms an Ethereum node. And there is also another optional client is the validator client. That is also an Ethereum node. We can call them an Ethereum validating node. All these components can be run in a single computer. It can be a desktop, it can be a laptop, or some people like to use this mini PC called Intel UC or Asus UC. Okay, so just now we talked about all the clients can be run in a computer, right? Laptop. So you probably have a laptop, and you may start to think, I also have a laptop, so can I run a node? Which brings us the question of who can run a node? And the answer is yes, anyone can run a node because Ethereum is permissionless. Permissionless means that you don't have to obtain permission from a central authority, say that you want to run a node. You can just run it if you want. And there's no such thing as so-called application form where you have to fill in an applications and obtain approval from a central authority to say that you run a node. So that's so lame in the Web3 and blockchain space. So yes, anyone can run a node because Ethereum is permissionless. Knowing that anyone can run a node, then brings us the next question is, why do you want to run a node? Why should I run a node, right? So why should I? There could be a lot of reasons. One of it is, for example, you want to learn about how the Ethereum blockchain works in general. And trying to set up a node on your own is really a good way to learn about how the blockchain works. You will see how your node syncs with the network. You will learn about how to set up monitoring, upgrading the software, and so on. So the first thing is because you've got this hands-on experience, which is very invaluable when you try to spin out node on yourself. So really, when you try to set up a node, then you will really learn a lot from it. Another reason is there's often talk about is about trustlessness. Trustlessness means you don't have to trust a centralized institution. For example, when we growing up as a person, right, we used to think we can trust a centralized institution, for example, our banks, right? But can we really? Because we have seen a lot of cases, for example, leaked database over the years that raises a lot of privacy concerns. There are also examples of system downtime, widespread downtime of banking system that is really frustrated that you can't use a service when you want to use it. Right, so yeah, that is something that could happen really when you depend on, when you trust on a centralized institution. So what trustlessness can help us to achieve is that we don't have to rely on a centralized institution or any third party. For example, if you have performed a transaction on Ethereum before, you probably use MetaMask to perform Ethereum transactions. And MetaMask has this endpoint here and the endpoint is like, because Ethereum blockchain is a network, so there will be an endpoint for you to reach the network, right? The endpoint is like a gateway for you to interact with the Ethereum blockchain. So MetaMask by default will use Infura endpoint, which is a third-party endpoint. But if you run your own node, you can actually use your own node as the endpoint to reach and directly interact with Ethereum without any middleman, right? So by doing so, you will achieve total privacy because it's directly between you and the Ethereum blockchain. There will be no middleman involved. There will be no concerns of privacy. There will be no concerns of leaked information, right? So that's something that you could do. And as long as your node is available, you don't have to worry about downtime also. So that's something that trustlessness can bring us. Another reason you can want to run a node is you can have access to blockchain data because you will have access to query the API if you run your own node. Yes, there will be providers that provide API queries for you to access blockchain data. For example, you are interested in maybe some transactions of blockchain account, right? But the provider against usually come with limited access. They will limit your query. But if you run your own node, you literally have unlimited access to all kinds of blockchain data that you may be interested in. So you can query your own node as much as you like. Thanks again for running your own node, and you don't have to rely on any third party, and you don't have to trust any third party really, because you know that you run your own node, you definitely can trust your own node that you're running. One more reason could be that you can earn rewards by running validators. This is about financial incentives, because if you have validators, you can earn rewards when you run a node. Put simply, you can make money by running validators. So there are a lot of reasons really for someone to run, so these are some examples. Okay, so you may have some doubts you may have some doubts about running a node. For example, here we will cover two. The first one is that your node needs to be online 24/7. The answer is that if you don't have validators, you don't have to worry anything because there will be no penalty incurred. So for example, if you just want to set up your computer to run a node for testing, for example, you want to set up for a few days, and you worry that if you turn it off, then it may break anything. So you don't have to worry about that because as long as you don't have validators, there will be no penalties. And if you're offline, and then later on you want to connect to the network again, you can sync from where you left off previously. So as long as you don't have validators, you really don't have to worry about keeping it online 24/7. So if you just want for testing, then you can just set it up, and then if you want to turn it off after some time, as you wish, right? There's no worries at all. Another doubts that you may have, probably a perception that people have, is that running a node is complicated and uses a lot of electricity and high-end graphic cards, GPUs. This is probably because over the years we have seen a lot of news headlines in newspapers that someone is stealing electricity from TNB to turn some random place into a Bitcoin mining farms. You probably have seen this kind of news before, right? So that gives a perception that running a node is complicated, uses electricity a lot and things like that. And again, that's not true anymore because Ethereum does not do mining anymore. Ethereum is now fully proof of stake. And in fact, Ethereum is designed to run on consumer computers. Consumer computers here means that the computers that you can get readily from any shops that is available from you, laptop, desktop, whatever, right? So this can be nicely put into a meme like this, where the meme guy is not happy about mining. This is what you see on the news headlines, where someone is stealing electricity from TNB to do mining. This is what mining is about. You see a lot of graphic cards, ASICs, cables, computers, whatever you name it. And that is not the case for Ethereum anymore. Ethereum now is fully proof of stake, and you can run everything from a single computer like this. So no, you do not need high-end graphic cards or high-end computers to run a node. And it's actually the very opposite. It can run on consumer computers and you will use very low electricity. It doesn't do mining anymore. Okay, so there's some information already. And if you're interested to, for example, want to try to set up your node, and where do you start? And this is a very good resource to get started. It's ethereum.org website. It's a very good and comprehensive information about how to run a node, and all the information that you needed is, you can give it a read if you want to give running a node a start. It's a very good website, really. This contains all the information that's needed. And what do you need? How do you start? You really only need a computer and internet connections, which I believe all of you here already have. And if you're not comfortable with mainnet, you can start with Woody testnet that's tailored for staking related stuff. Testnet is like, it's also a live network. It's also a blockchain. It's just that the tokens on the testnet is not real ETH. It's testnet ETH that has no value. So on testnet, you can do anything that you like. You don't have to worry about what if I've done something wrong, what if this, and what if that. So you can go full force on testnet because that's the reason testnet exists. And if you, in the process of setting up a node and if you have issues, you can go to ETHKL. It's a very welcoming community of ETHKL. They are available on Reddit and also Discord. Or if you use a client, each client team also have their own Discord or Telegram support groups. So if you run into issues, don't be afraid to ask questions because there are a lot of avenues and places for you to ask questions and get your problem solved. So don't worry if you run into questions, if you run into issues. Okay, and this and next slide is a little bit of screenshots of demonstration on what running a node is about. So we have this tool for in Ethereum where we call it dApp node. It's a graphical user interface tool for new users to kickstart of how to run a node. It's very beginner friendly because it provides this user interface where you can just select the client and click next and so on and so forth. And if everything is smooth, then your computer may start to sync the network in a very short time. So these are the tools that that's available for new users to get to start running a node. And similar tools are also available. For example, ETH Docker that also provides similar UI interface for you to click and select. And also ETH Pillar from CoinCasue is also has this user interface. And another way for running a node is that involve command line interface, which does not have the user command line interface that does not have the UI as in the previous slide, which involve typing some commands in a terminal in Linux. So you will involve opening a terminal in Linux, or in the case of Windows, it's called command prompt. You know, the black thing. When you open a command prompt, it's a black screen, and then where you can enter the commands. Yeah, that will allow you to set up a node, for example. Right? So take for example, Lighthouse consensus client, how you set up Lighthouse. By the way, as a Penang Lang or Penang people, when we talk about Lighthouse, you probably start to think about the Lighthouse in Fort Cornwallis that is literally 5 minutes down the road here. Or another one in Mukahel Lighthouse in Penang National Park, Teluk Bahang. They are also Lighthouse, but the Lighthouse here we are talking here is an Ethereum consensus client that is implementing the Ethereum protocol. It's a consensus client. Okay, so and Lighthouse has this documentation called Lighthouse Books that provides the instructions on how to set up the beacon node. The comments is here, Lighthouse BN. BN stands for beacon node and followed by a few commands here. So if you want to set up a node using command line interface, you can follow the commands like this that is provided in the documentation. And then after you press enter, then the computer will start to run Lighthouse. And just now we mentioned we also need execution client, right? So it's not shown here, but you need an execution client as well. So this method is a bit more involved because it doesn't have user interface. It's a bit more hands-on, a bit more manual. But at the end, the computer will become a node, just like previously, the previous slide. No battery. No battery. Okay. Yeah. Okay. Yeah. Sorry. Yeah. So how it looks like when the node is ready, right? It looks like this. There's a lot of logs involved, but you don't have to worry. Can you see this? We see new block received. We see new block received in the log. Remember the block just now is the block that will contain the transactions. So your node is receiving new block from the network, and we see new blocks keeps on coming in from the network regularly because there will be more and more transactions to be added to the blockchain, right? Another thing that we see is that the nodes is connected to peers 100 and 05. The peers here means, let's say 100 lah. The peers here means other nodes lah. Okay, so your node, this single node alone is connected to 100 different nodes in the network as well. And there are a few more other cryptographic things. We are not going into details. And remember, all these processes are running in a computer, and it can be in a laptop, a desktop, or a mini PC. And just now we see that a node will connect to other nodes, right? So if we denote a node as a red dot, it looks like this. And in Ethereum, there are 10,000 nodes globally distributed geographically all over different locations, forming a decentralized network. And it looks like this. Each node is run by different people, different entity. It can be run by people like me or you, which is something really cool. The node contributes to the decentralization of the network, making Ethereum more secure. The node allows you to achieve trustlessness. For example, you can submit transactions without relying on any third party. The node will also help you to independently verify the validity of transactions. If you run a node in practice at home in real life, it will be something like a computer sitting in the living room doing all sorts of magics right in front of you, which is something pretty amazing if you think about it. All right, so hopefully that gives you an idea about running an Ethereum node. Thank you. Any questions? Yes.
Slice of the maybe, right? Is that something that's very easy to do, or is it complicated?
You are saying that you want to use MEV, right? You're not building your own builder, right? You want to use MEV.
Yeah.
Yeah.
Someone else to build blocks for me and report me.
You can. Literally in the UI just now, there will be an option for you to choose, for example, or in the CLI option just now, you can add a flag, for example. Say you want to use MEV. Yeah, you can do that. You can do that, definitely. Yeah. Yes. If you have validators, yes, if you have validator, you will have to worry about keeping it online 24/7 because there will be penalty. But the penalty is very mild. Penalty that we are talking here is, I don't have the exact figure, but it will be like, let's say if you're offline for a day, you can make it back by online for another day. Do you get what I mean? Yeah. So if offline for a day probably costs you about 20 ringgit, maybe a day, costs you about 20 ringgit, and then you can make it back by online another day. Yes, it will, but it's very mild, only 20 ringgit a day, about that figure, about 20 ringgit a day. So if you, let's say you're offline, let's say your internet is down for maybe 1 hour, then it will maybe be like 1 ringgit, more, probably less than that. Yeah, it is very mild. The offline penalty is very mild because it's designed to keep small stakers in mind. Because if people like small stakers, home staker like us, right, we don't have the high-end infrastructures to keep everything online, right? So the penalty for offline is very mild. I don't have the exact figures, but it will be something like 20 ringgit. I'm not too sure, but it's mild. It's mild. 20 ringgit a day is about